Hello again, everyone, and welcome to our next lesson, more applications of linear equations. In this case, this is section 2.4, but we could call it 2.3 part 2, the sequel. So in this case, we're just going to do a quick review here of more word problems and going again from those word problems to math expressions. So again, here are more links again from the previous section to our table of common phrases, both on our website. It can be found in your book in the beginning of section 2.3, as well as again the link to our little review game of Math Expression Millionaire. Since this is a sequel, no need for backstory. We're going to dive right in and continue on where we left off at example number 5. Now, we have a bill totaling $5.65 that a cashier receives, and he gets 25 coins. That's all nickels and quarters. So how many of each coin does he receive? So the first thing we need to do, we need to assign our variable. In this case, we're going to let x be the number of nickels. Now, we could easily make this the number of quarters, and doing that would not be wrong. It's just, for this, we're just going to call it the nickels. If you do with the quarters, that's fine. Your final answer should, and I again say should, be the exact same answer that we end up getting here. So for this, we're going to set up another table. And a lot of word problems, setting up a table is actually going to be very helpful. So in this table, we get that we have our nickels, of course. We know we have X number of nickels, and we must have, since we have 25 total coins and X of them and an X number of them are nickels, that means 25 minus X has to be the number of quarters. So say if we know we have 25 coins and say 10 were nickels, that means 15 of them have to be quarters. Since we don't know how many there are, it's X, we just know it's going to be 25 minus X. And we also know, even though it's not overtly stated in the problem, just from everyday lives, just how much a nickel and a quarter is. A nickel is 5 cents, a quarter is 25 cents. So that means the total value of all the nickels that in this is 5 cents times the number of nickels we have. So 5.05 times X. The value of all of our quarters is again 25 number of quarters, 25 minus X, multiplied by the value of each quarter. So we get 0.25 times 25 minus X. Now, we know then that the total value from the word problem, the total value that was paid was $5.65. So we are going to take these two, the value of our nickels and quarters, we're going to add them, and together their value must equal $5.65. So we just take that last row and column and we just add it. 0.05x plus 0.25 times 25 minus x equals $5.65. So now we've got our little simple linear equation in one variable. So now we just go through our steps again and we solve it. Step 1, simplify both sides individually. Well, of course, this side's, you can't get more simple than a single number. So here we just distribute 0.25 across, so we get 6.25 minus 0.25 times x equals 5.65. Now, I am leaving these in decimal form. You could, theoretically, go ahead and multiply this whole thing through by 100, so that way you're not dealing with a single decimal, and that's fine. In fact, it probably would have made this problem a lot simpler. I am simply leaving them in this form because we are dealing with money, and money is usually dealt in 2 decimal places. Because we're dealing with money, I am just leaving it the way it is. So now we combine our x's to simplify it further. So we get 0.05 minus 0.25 to get a minus 0.20x, which equals 6.25. So now that we've done that, step 3, isolate x on a single side, which we have already done. So we can skip step 3 on to 4, and that is isolate a variable by itself. So now we need to subtract 6.25 from both sides because it's added. So we have to do the opposite. We need to subtract it so that way it gets rid of it, cancels itself out right here. And then this simplifies out to negative 0.60. So now we've got x, we've gotten rid of all that little extra stuff. Now we need to get rid of what's in front of x. So now we need to divide both sides by negative 0.2 so that these cancel each other out. All we're left with is x. And this gives us a final answer of 3. So of all 25 of those coins, 3 of them were nickels. So that means our final answer is not 3. Our final answer is that the cashier received 3 nickels and 22 quarters. Just because we found an x equals 3 does not mean we're done. We need to make sure does it fully answer the question. Because it says each type of coin, not just nickels. And of course, we can easily check this on the table by simply plugging in 3 for x. So we have 3, 25 minus 3 is 22. Multiplying out, that's 15 cents worth of nickels, $5.50 worth of quarters, which totals to $5.65. So now let's look at another one. These are 2 cars in the same place, and they're going in completely opposite directions. One travels 40 miles per hour east, and the other goes 50 miles per hour west. How many hours will they be 300 miles apart? So if one goes 40 in one direction, the other goes 50 in the complete opposite direction, how long will it take before they're exactly 300 miles apart? Well, since what we're looking for is time, how many hours, why not just make x time? If you want to make it t instead of an x, that's just fine. If it makes it easier for you for your problem, then go for it. So now, again, we're going to go with a table, and we're going to fill it out. So we have an eastbound car. We know that its rate is 40 miles per hour. It traveled x distance. It traveled for x time. We don't know how long that is yet. So that means the distance it traveled is 40x. And we know this because of, from 2, this is the distance formula. Distance equals rate times time. So 40 times x equals distance, so 40x. The westbound car was going 50 miles per hour for the same amount of time. So that means the distance it traveled is 50x. And again, we need to take these two and add them together because we know that the total distance is 300. And the only reason we know we're adding them together is because one car is going west from this point, center point. The other is going east. So that means the total distance, this total distance here is 40x. The total distance here is 50x. So that means this total distance here has got to be the sum of them, which in this case would be 90x, which I'm getting ahead of myself. And actually I have just now realized I have got these backwards. This should be the 50x, that should be the 40x. Oh well. Anyways, that's the general idea. This is why we know we're adding them together. So again, we know we have 40x plus 50x equals 300. So now step 1, we already know is to, simplify both sides. So 40 plus 50 is the 90x. So 90x equals 300. So now we can just skip all the way to, we want x all by itself. So we're just going to divide both sides by 90. And so 90s cancel out. So we get x is 3 1/3 hours, or 3 hours 20 minutes. Both of these answers is correct. In fact, I will in your homework assignments, I will take either way. You just need to make sure that you're careful, because 1/3 of an hour is 20 minutes. However, I will take whatever you get right for the final form. So if you write x equals 3 1/3 hours or 3 hours 10 minutes, I will deduct a point, because that's, well, not the right answer. You were close. It just means you just converted that 1/3 of an hour to the wrong number of minutes. It happens. It's not a big deal, but I will deduct points for something like that. This problem is going to go a little bit different than what we've been doing. So let's go ahead and get started. All right, Jeff bikes to work in 3/4 of an hour. If he takes the bus, it only takes him 1/4 of an hour. Now, if the bus travels 20 miles per hour faster than Jeff rides his bike, how far is his workplace? Now, you would initially think that since we want to know how far, we want x to be distance. And again, like I said, 9 times out of 10, 99 out of 100, that would be the right way to go. Unfortunately, in this case, it doesn't really help so much. And the biggest reason is because of this part. The bus travels 20 miles per hour faster than Jeff rides. So actually, the first thing we need to know is, how fast does Jeff ride his bike, and how fast is the bus traveling? So, since that's something we don't know, best thing to do is, let's make that our variable, and let's make that what we don't know. So we're going to let x then be Jeff's speed on his bike. Now, again, we're going to set, since we're looking at speed, times, and distances, that sounds like the distance formula. So we'll set up a little table using our little distance formula, and we get that when he bikes at some rate for 3/4 of an hour, and that gets him a distance of 3/4 of x. And that's because, rate times time gives us distance. So we do the same thing down here. X plus 20, which is how fast the bus travels, 20 miles per hour faster than he rides his bike. And if he rides the bus for 1/4 of an hour, he gets the same distance. So multiplying these two together gives us 1/4 of x plus 20. And you'll notice there is no table down here. And the reason for that is because in this one, we know that the distance he rides his bike is the same as the distance he takes his bus. So in fact, these two, we're not adding them. We're actually going to set them equal. We're going to say this distance is the same as that distance. So we get 3/4 of x is the same as 1/4 of x plus 20. So step 1, we need to get rid of fractions. So the easiest way to do that, of course, is to just multiply both sides by 4. And that way these right here will cancel. This here cancels. So we get 3x equals x plus 20. Now we get to the next step. We need to move x over and isolate it on one side. The easiest way to do that is to get rid of this x. Since it's positive, we need to do the opposite of it, and that is to subtract it from both sides. So this x minus this x will destroy each other. So we're left with 3x minus x equals 20, or 3x minus x, which is just 2x. Now we can do our last step and simplify by dividing both sides by the 2. So we get 2x over 2 equals 20 over 2, or x, which is 10 miles per hour. So Jeff rides his bike for at a speed of 10 miles per hour. Now that's not the final answer. It's close, but remember, we want the distance. So we know that the distance is rate times time. So we know that at 10 miles per hour, he travels for 3/4 of an hour. So multiplied together, that gives us 7.5 miles. And that is the total distance. Now, if we'd have done this the other way and gone with, instead of the bike, if we'd have switched this around and gone with the bus would have been 30 miles per hour at a rate of 1/4 of an hour. And if you can check on your calculators, that will give you the exact same answer, because we already said the distance he travels on the bus was the same distance he traveled on his bike. Now for our final example, we're going to look at determining the value of x for the measure of each angle of the following triangle right here. Now we know, so we're going to designate this angle, well, we don't, it's already designated for us. The angle here is x degrees. This angle is 20 more, and this one is 3 times the original less of 210. That's a little bit of a mouthful. So what you should remember from your geometry classes is, of course, the properties of triangles. Triangle, the sum of all of its angles must be 180. So we're just going to take this and just add all the angles together and just set it equal to 180. So we have angle 1 plus angle 2 plus angle 3 equals 180. So first, we need to simplify. So we're just going to take x plus x minus 3x to give us negative x, 20 plus 210 to give us 230, and that gives us 180. So again, we want to get x all by itself, so we're going to subtract 230 from both sides. So that way here, these destroy each other, and this one stays put and gets taken away from the 180. So we get negative x equals negative 50, which of course you can either divide by negative 1, multiply by negative 1. Either way, the negatives cancel out, and you get x is 50 degrees. Now that's not the final answer, because that only gives us our first angle. We need this angle and this angle. So we know that, so that means the three angles are 50 plus 20, which gives us our 70, our angle 2, and 210 minus 150, because 50 times 3 is 150, and that leaves 60 degrees. So this was a 50, 70, 60 triangle. And of course, if you check with your calculators, you'll get 50 plus 70 plus 60 is 180. Again, links here to review and relook at any of our examples and stuff. We'll go back to our math expressions game, the little table. If you do have any questions, post in the comments, post on the site. You know the drill. And again, have fun. I will see you all in class next time.